Well, welcome everyone to the session on DevSecOps for APIs. My name is Isabelle. I'm the field CTO, so basically I'm mostly working with partners and customers, and the co-founder of a company called 42Crunch. Who has heard about 42Crunch? Well, I'm allowed to. Well, that's not bad actually, right now. Great job. So what do we do at very high level? We do, as you can imagine, security for APIs is what this is all about. And this session, so it has some aspects to what our platform is actually doing, but there's some other stuff as well, because for me, DevSecOps is not about putting just one tool in the pipeline. It's much more than that. So we'll talk about other tools. I'll even show you some things in SNCC and other tooling, and we'll talk about some of the things you can put in place for really implementing DevSecOps in your company. So there's really a mix of presentation and some labs that I put together for you to tag along. So if you want to tag along, you will need to be connected to the internet, and you're going to need just basically a GitHub ID and connection to GitHub. That's pretty much it, okay? So any questions? Of course, this is a workshop, so it's actually much better if it's interactive than if it's not. Without further ado, let's get started. Okay. So what are we talking about when we talk about DevSecOps? So first of all, now before I say anything, does anyone want to give me a definition of what putting DevSecOps in place is? Or what are you doing maybe in your company about it? Any volunteers? Apparently not. Okay. Right. So frankly, the main problem that we see at our customers today is, maybe you can answer to that question. How many APIs do you have in your company? Let's say more than 10. Pretty much everybody, right? More than 100, right? More than 1,000. So a few as well, right? So when you get to those numbers, when we started all this journey with APIs, when we had just a few running around and they were called web services, and right, we really didn't care so much about automation at any level. Should it be security or something else? Simply because, well, doing things manually would scale. But now that doesn't work anymore, right? Like every single customer we work with, indeed, they have 500, 1,000, and this is what they have now, and this is what they know about, which is another thing we will talk about. Right, and this is no way in stopping in progressing. This number is just going to explode over the next years, that's for sure, right? So automation basically is our only survival kit here, right? If we want to do anything, should it be functional testing, security testing? So this is all about security because that's what I mainly care about. But you can apply this to pretty much anything you have to apply and do as part of the API lifecycle, right? So what are the challenges that we see in security today, right? What are people telling us? Well, the top 3 things that I hear from people is this. A, we tested all the APIs last month, right? Just like, okay, what happened since last month? You probably have like 10 new APIs or 100, who knows? They probably each have changed, I don't know how many times, right? So from a security standpoint, so it's really tested from a security standpoint, right? That's really not enough, because every time something is changing, you want to do security testing again. The other big one is, yeah, but come on, we're covered, right? We have those guys, they come in-house, they do this big pen test, they find all the problems, and they'll come back in a year from now, right? As if security is a one-off, like we test it once and that's it. We can wait until the next year and the next pen test to actually test it again. And the other one is actually, you know, this is not so much what we do because we're very much more at the app level, but people are extremely surprised by the number of dependencies that they drag in when they create an application. It doesn't really matter if you create a Node application, a PHP application, you know, every time you go like import X, right, you're dragging in code which is not yours. And this code is dragging more things which is not yours, and that code is dragging more things which is not yours. Right? And then we lived that in my company when the first version that we had of our platform was written in React. And we had to do this due diligence for an investment. And one of the things from the due diligence was give us the list of things that you're actually depending on. So we had to create this nice graph thing And from the like maybe 15 or 25 things that we were actually importing ourselves, we ended up having 1,600 dependencies, right? So how do you manage that, again, manually? How do you know you're not dragging in version 1.2 that drags version 1.3 of something else, that drags version 4.0 of something else, and 4.0 has a problem, right? So that's the key thing that, you know, so scale really of testing and scale of implementation is really the key problem here. All right, so what else has changed? And this is really something that SNCC talks about. This is actually coming from them. This is a great blog about the evolution of application security in general, right? Where we are actually in the world now where most, if not, you know, of the responsibility of the app stack ends up in the developer's lap, right? So it's not only about the code, obviously, and the libraries that we're bringing in. It's also anything with, you know, my container image, and I need Mongo, whatever, 3.8, right? And Nginx 1.17, and XXXX, all the things that we're actually depending on for application code to actually run. And on top of that, we're adding all these things related to the infrastructure. You know, the minute you do service mesh, Kubernetes, and all of this stuff, that also falls into some people from development writing down what this infrastructure actually going to be, right? So that stack that we have to validate and that makes up really our implementation is much, much bigger than it used to be, right? So again, we really need to rely on, you know, automation here to make sure that every single layer, there's no way we're going to control all of this, right? So every time we make a change. So, you know, by then you're probably convinced now automation is the key. So how do we scale this, right? Well, we scale this really by automation, right? So mid-DevSecOps. So what is this all about, right? So really, the first thing is, as I was mentioning at the beginning, for me, DevSecOps is really, it's a culture. It's a different way of doing things. It's not a product, right? So we, as 42Crunch, we participate into a DevSecOps approach within companies. We help companies implement DevSecOps, right? So it's really about, we coined that term, which is security as code. So the same way when we wanted to automate infrastructure, right, we needed a way to represent what is my infrastructure. And this is where we got the Ansibles and the Chefs and the Terraforms of this world that allow us to describe an architecture, an infrastructure, and we run this thing. And we can run it 15 times, and we can run it in different environments. The output result is going to be the same, right? So we want the same thing for security, and this is where OpenAPI has a role to play, as I will, you know, and standards in general. So the ability to describe, this is the security of my system, and I want to make sure along the life cycle of my application and my APIs, I can make sure that this security is actually as intended. I can enforce what has been, you know, the recommendation of my security teams in terms of what has to be done, and I can enforce that both from a testing point of view and from a runtime point of view, right? So that's really what we want to implement. And, you know, this is also where you're going to start hearing about shifting left, right? Which is really about making sure we start worrying about security in particular as early as possible in the life cycle of the APIs. Most of the customers don't know what happens. You know, you have the dev team, you have the security team. There's a kind of a, not so much virtual wall between the two, right? And when an application is done, we kind of throw it over to the security guys and we say, go, test this, right? And that doesn't work too well, right? Because there's this lack of understanding between the two teams on what it is that we're actually testing and working on here, right? So we need much more, you know, collaboration between those teams. But for that, right, we need to actually equip the development teams as well with more security tools, which are developer focused, right? So what shift left is not, is just taking the tools we've given to the security teams on their life and putting them in the hands of the developers, right? That doesn't work. Actually, one of my colleagues has tagged this as being shove left. as opposed to shift left, right? That doesn't work because those tools are not made for developers at all. They're made for security people. The focus is completely different, right? So shift left is really more about how can we empower as early as possible developers to have that security knowledge and security tools so that, you know, my dream is in the end, we get at the end of that flow of development of my APIs and there are no problems in my APIs. You know, we don't find anything when we do the next yearly pen test. That is really what should happen, right? That will not happen if we're not worrying about security earlier, right? So again, what DevSecOps is not a person. As you know, say we want to hire a DevSecOps person. Well, maybe you're going to hire somebody to oversee the DevSecOps program and help putting all this stuff in place. But again, DevSecOps is not putting all the responsibilities onto the head of a single person. That doesn't work either, right? So what it is, it's really a change in culture. That's why, you know, it's like DevOps. We had to change the way we were working. So again, this is why I'm saying it's not about tooling. You need tooling that helps, but it's about wanting to change how we're actually working, right? So a change in culture for everyone. We want everybody to work together. It's all about establishing processes that we can enforce, right? And giving the right tools to actually implement those processes, right? That's really what, for me, this is all about. Any comments or feedback on this? You agree, you have the right to disagree as well. You have the right to agree, and you have the right to disagree, and you have the right to comment. Yeah? All good? Anyone? Okay, cool. All right. So what are the benefits of this, right? Again, everyone is responsible. That's the main problem right now. Another number I'm going to throw at you. I was at the security conference about 2 months ago when somebody said that right now there's about, in large companies, there's one AppSec guy for 130 developers. That's the ratio, right? Maybe 100, maybe it's 50. But basically you have 130 people who are equipped with like clicking on 2 buttons and boom, 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 it generates code and everything. And then you have a poor guy in front that tries to secure all of that. That's really what's happening in many places right now, right? So that's why we need to take out of their hands, I would say, the responsibility for some of the basic stuff that we could do automatically. So, and indeed, their core responsibility probably is those maybe more red team type things and pen testing, etc., which are not things we can automate, right? We need a human to kind of pull from the thread and attack our APIs in a different way. Obviously, the idea is we are secured by design, right? So we start by implementing things in a secure way. So this is a pattern I see at many places as well, is we develop all the APIs with 0 authorization, 0 authentication, right? And we're in pre-production say, oh, by the way, we should really put whatever, an API key or some auth in front of this. So we'll just throw it into an API management and it will do that for us, right? Which means you haven't done any testing, nothing with security on. Right? So you really want to do that much earlier in the life cycle, right? So we want people to really learn about the best practices also around security. So how do we do that? And the idea is really to continuously improve the security. Right? We'll talk about some of the methodologies we've been working on with our customers as well, right? So that's kind of the dev cycle. So this is something, there's this great article again, which has been written originally by Jeff Williams, who's the CTO of Contrast, and if you know OWASP, is one of the key authors of the infamous OWASP top 10 and many of the cheat sheets around security, etc. And they wrote this really nice ref card at DZone, which is completely free, to explain like the principles of DevSecOps and the methodology to adopt it. And frankly, it's very much in line with what we are defending as well. So I kind of reused their work here, and we're going to go and adopt this. So the first thing is analyze. So what is it that we need to secure, right? And really, the first thing here is, as they always say in security, you cannot secure what you don't know. So if you don't know what you have, if you don't know what your APIs do, if you don't know the data they manipulate, it's really hard to decide what the security should be, right? I'm going to ask you a question. What is security based on? What influences, if we're going to put some very stringent measures in place or, yeah, light measures in place. What should you know about your APIs? What type of people are using them? Yeah, what else?
A lot of focus on data, because I've been to GDPR jail and other things.
GDPR jail.
It is so critical, even understanding within a set of APIs, it's again, who you're talking to and who can see what, and that goes all hand in hand with this problem. And I've had problems with people putting data in APIs and not really understanding who was using those APIs.
Exactly.
So saying that in the hands of like a, you know, in the developer department or the people that actually do bookings in airlines, they know not to use some of this data. The retail people, on the other hand,
Without saying names, okay.
provide this person and they'll pay for it, and it's even not even knowing they're going to inadvertently use the same APIs to expose data to people they shouldn't be exposing it to. I've never found it's been tough to attack that type of problem.
It is tough, but so the first step really for me is to know this, right? Which data is sensitive for your industry, which is not the same for insurance, most likely, right? In travel. Indeed, who is going to access that data? Who is authorized to access even, and it's very precise, you know, information. It could be at the field level, right? There's some fields we don't want to return because it's PII, and as you say, it's GDPR, and et cetera, et cetera. We have to know that, right?
And it's the mesh of identity management. So
Yeah.
how do I know 3 hops down the road who's looking at this now? Because I've lost contact.
You lost the track on it, exactly, right? So the word I was looking for is risk, right? So what is the risk of exposing that API? And I have this good friend, Keith Casey, always tells this story, and I heard that, you know, recently again, of you have a team in a company, they have this need, right? Just for their application. So they create this API for them, like just for this internal thing, and it's only for them, and nobody else is supposed to see it, right? But then somebody sees that API and says, oh, this is really cool. We could use it across the enterprise, right? So they will just start now to expose that to more teams. And then somebody else comes in and says, oh, we should really expose this to our partners because they will be super interested to get access to that information. And then suddenly Joe Doe can access this thing, right? What have we done along that way? Have we reevaluated the risk of what this API does and the data it exposes, et cetera, et cetera? Probably not, right? And that's a source for tons of problems. So, you know, normally in application development, we do this thing called threat modeling, right? And then we should really do that for APIs. When we start working on APIs, so what is it? You know, what are the actors and what are the potential risks, et cetera, so we know what we're doing, but instead of just jumping straight into, you know, code level, right? So that's the first thing. How do we do threat modeling? And then the other thing is, what is it that we have? So that's the other main problem I see everybody has, right? What do we have? What APIs do we have? I talk to security people and like, I don't know, I could have 1,000, 3,000, or 10,000 for as much as I'm concerned. I have zero control over them, which is crazy because they are the ones that will be responsible if something happens, right? In the end. So let's talk about discovery, okay? So the first thing usually people come to us and ask about is like, how do I know what I have, right? So there's two things that we're doing today in 42Crunch. I'm going to talk about what we do, but there's plenty of other tools that do things a bit differently in different ways, right? There's basically two levels of discovery. There's, you know, discovery, I'm sorry, from repositories and from all the information that I have. Let's go and look through all the code, right, and see what we find. That's one thing that we're going to do right now. And the other thing is to do discovery also at a runtime. For me, it's a bit late in the process, right? But there's a lot of tools right now on the market that just will put themselves somewhere in the traffic and start listening to what you actually have to be able to tell you, hey, there's all this stuff that you have forgotten, or all this stuff that's new, it's not known anywhere, etc. Right? So there's two aspects of doing this. So let's do it through discovery in GitHub. So this is where GitHub gets into play for you guys. If you want to go and tag along. So I have this project. So if you go to GitHub, this thing 42C pre-sales, audit integration. So it's a public project that you can actually go and fork, right? So you'll be able to then run it into your own environment on GitHub, okay? So you'll simply fork this. I have done it before. All right. I should be able to do that. And then with the same GitHub ID, what you can do is go to our platform and just click on that button. So because you're already using GitHub, you might as well click on the GitHub button as well here. So this will take you through our platform so that when we execute the actual discovery, the files that we will discover will be uploaded up to the platform, okay? So normally if you just click on this, click on GitHub, you're already logged in, you're gonna go straight in after accepting a little thing, and that's all, and you will be right in there, okay? So once you're good, everybody, pretty much, right? So let me explain a bit of what we do and the first thing we do. So there's this tool we have, which is called the audit, right? The idea of the audit is to do this analysis of, from a security standpoint, based on your definitions on the OpenAPI file definitions, right? So should you take a code-first approach and generate the OpenAPI file from that, or should you take an API-first design approach and start with the interface? Well, both work, right? So let me show you what that looks like in the platform, since I'm already there. I'll just go and import an API in there. For example, this guy. So we'll just crunch the data. Here we go. All right. So actually, this one is pretty good. So what the audit does, it's going to create a report on two aspects of the OpenAPI file. It's going to look at the security aspect, which is what is it that you have decided in terms of security? Is it basic authentication? Is it an API key? Is it auth? If yes, what type of auth? Is it going over HTTP, over HTTPS? Is it in the header? Is it in a query? So anything that can, affect how solid is your authentication authorization mechanism, okay? So that's the first thing. And the second one is about data, right? So this is really about constraining your data. So when people create contracts, what we see a lot is they're very loose, right? The definition of the data coming in, coming out is very loose, which means that if you do any type of validation against the schema, it's going to be very poor, right? Because validation is only as strong as the definition that you're validating against, right? So what we're going to tell you here is, hey, you told me this is a string, or you told me this is an integer, or you told me, give me more, like tell me more about this. What is this pass thing, right? What are the constraints? What's a password for you? Is it 64 maximum, or is it 128? So some people, depending on who you are, right? Is this an email, or is this a credit card number, or is this whatever it is, right? and for every single of the problems that we find, you will see here on the left, a description of what the problem is and remediation about it. So the idea of this is really to educate the developers on, hey, this is really what the problem, the root of the problem is, and that's how you actually have to go and fix it and give us information, right? So what you're seeing here is the SaaS platform. So obviously a developer doesn't want to work there, right? That's not what they want, right? So what they will actually do is most likely go to Visual Studio Code instead, right? So let me just go and click on here, right? So we can see exactly the same thing. I'll just clean up a bit this in here, okay? Let me just zoom that a bit so you can guys see. Oh, that's out of zoom. Okay, so here we're just connected to the platform from Visual Studio Code. We have a plugin for that. I know a lot of you are using our OpenAPI plugin. You know, I know a lot of you do because we have 500,000 people using it. So we have several people telling me this morning. So as part of the plugin, so you have like a free section, if you want, of it that allows you to edit OpenAPI files and work with them. But there's also, if you're actually entering your credentials to the platform, then you also see as a developer the same thing you see in the platform itself. So this file we just imported, it's right there. We have that same audit report, right? The difference is going to be that now I can see those problems in context within Visual Studio Code, okay? So all of this is all connected. So if you want to do what I'm doing, if you're all on the platform now, I guess, let's do this together. So let's connect all of this. So if you're on the platform, here on the top right, you'll see something called API tokens, okay? So what you want to do is you want to create, well, let's create one for now, just not be fishy. Just create a new token, right? Keep that value, create something that lasts whatever you want, a month or something. And just do the test token this way, okay? Let's say it expires tomorrow or something. And you want it to have a security audit scope as well as those two, because we're gonna delete some stuff as we go and set things up, okay? So this is going to create a token that you can see here. That's just a UID and with API return in front of it, okay? And just save that, or don't close that window, because once you close it, you will not be able to see it again, all right? So if you have now, that's not what I wanted to show, sorry. So if you have cloned this thing in your environment, okay? So in my case, this is my personal account, Zaz65, okay? So I've cloned it from there in my personal account, okay? So how do we do discovery with this now? So in that, in that project, right, we have a number of OpenAPI files. There is here something that says discovery, right? And there's a number of files that I got from APIs of gurus and different sources. And we're gonna go and import all of those into the platform, okay? How is that working? So inside that same project, you have a GitHub workflow, right? So you can go, and if you have the right to do though, under actions here, you should see that workflow, which you can run, right? And so what that workflow will do when it runs, it will go, it will fetch and find all the OpenAPI files within that single repo, and it will upload them into the platform. Now, for that to work, you need two secrets, right? You need, there's two secrets. You need the API underscore token, which is the token you just generated from the platform, from 42Crunch, right? Then you need a GitHub token because the thing needs to read to do the analysis, right? So you need to also create a personal token at GitHub and set those two environment variables. Sorry, two secrets, right? Variables. And if you do that, then you'll be able to run that actual workflow, and they will go and discover all the files and upload them. But needs any help? Are all good for people who are following? Yeah? Cool. All right, so if you run this, what will happen, right? So I can run it again. All right, so if I run that workflow again, what will it do? It will go, it will connect to the, it will, well, start to build, obviously. Here it goes. It will check out the project. And then it will call this static security testing. So this is GitHub. We have that for Azure DevOps, for Jenkins, Bamboo. We have a Docker image. Normally, wherever you want to, if you want to play with that later, anywhere, you should be able to do that. And it actually executes a Docker image, right? So then we'll go and find those files, and it will go and upload them. So that so it will fail in here at some point. That's because the environment in which we are is limited in the number of APIs you can actually upload. So it's going to fail after 3, but it executes the whole thing. So we should you will find a few files in there, right? Because we are past the thing. And so for every single file, and that's really what the important part here is. So we found this file, for example, which is the 1Password API YAML, right? So you see there's a score. Remember when we did this audit, it gives you this number, right? It gives you this score over 100. So what do we want to do from a DevOps perspective here? What are our customers doing? They say, okay, so the developers, they are in the IDE, they fix, they run the audit, they get all those results, right? All those analysis, they fix the issues, and then what they do is they take their code and they push it into whichever type of pipeline, right? So what companies want to do there is they want to, trust, but verify, right? So you want to verify that indeed the API that is being uploaded does comply with the rules of the company, whatever those rules are, right? So we have those things that we call security gates or safeguard, right? Which allow you to define what are those rules. So some of our customers, they say, well, the rule is everyone needs to go over 80, okay? Some others can say, for this group of APIs, it's actually mandatory to use OAuth, right? Or for that group of APIs, you have to use API. It's okay if you are using API keys. We'll let it go through, right? So you can take the results of the analysis if you want, and then add some rules on an analysis of that report. So if we find any kind of specific issue, you may want to fail on that, you may want just to fail on the score. That really depends on what you want to do. You can go as fine-grained as you want on saying this rule here, if it fails, that's a no-go across all my APIs, for example. There's more 300 of those, okay? So that's what we call the security gate. So in that environment, there is a default security gate that you cannot change just for the sake of demo environment, right? Where the bar is at 70, right? So if your API is not at 70, it's not going to pass the gate, which means we're failing that step, right? That's what you want to do because you want those errors to really pop up as early as possible in the life cycle of the API where it's, it's very easy to fix, right? If you discover in pre-production that, oh shoot, somebody has put API keys when they really should be using OAuth, that's going to be a big problem, right? So you want to discover that. Or somebody goes out of the corporate rules, I would say. You want to discover that pretty quickly, okay? So if we go to the platform now, we should see is this, what we call a collection has been imported. Here it is, right? So I have only one entry in here because I'm in the same conditions in which you will be, which is I'm top 3. No more than 3 APIs can be imported in that free environment, right? But you can see, the report in here and the score as well, the same reports, all the critical errors. So actually, for example, this is kind of interesting. They have this token, which is an OAuth token, but the server is they allow HTTP, which probably is not true, but that's what the OpenAPI file says, right? The OpenAPI file says that I'm actually allowed to pass a token in clear, right? Which you really, really don't want to do, right? So, yeah, tell me.
So at what point does this step happen? Is it at the upload of the API to the gateway, or is it happening before that?
So the question is, at what point in the API lifecycle does it happen, right? In general, at customers, yes, it happens before the deployment phase, basically, right? So you want to really, this is probably the first thing most people do in their pipeline is to plug this. to get this analysis and that information, right? Indeed. Yeah. Any other questions or comments? No? Okay. So what else do we have in here? So this is where, yeah, the security gates. So in an, you know, a full environment, so let me show that to you in a full environment where everything is, oh man. Type it right. Okay. So in a full environment where you have the ability to create your own gates, right? Then what you will see is you can put a rate on the fact that this is actually a valid structurally or that has semantic errors. You can have the scores in here. You can, as I said, put some specific issues in here and basically decide on the level of the criticity of the problems that we flag, whether it is okay. You know, so if basically what this means is from an authentication point of view, if we find any error which is high or critical, that's like, you know, breaks the build, even if the score is 95, right? And it's above the list. So you have to comply along all of that to actually pass the bar, okay? And of course, you know, if we do some discovered APIs, we can have much more than those. Then you can have some kind of, you know, more interesting information about the counts and the top problems, et cetera, okay? So that's discovery from a, I would say from a design point of view. And again, that's the main thing that we that can support today, okay? Yes, sir. A list of validation rules?
Yeah.
Yeah? Mm-hmm.
Right. So this kind of fixes says that you have or we can have our own set of validation rules.
I'm sorry, I misunderstood. I didn't understand.
So you are just showing that some things are wrong.
Uh-huh.
I mean, if you want to say what is wrong, you should be having some rules against which you validate.
Yes.
Is that a standard list or we can have our own custom validation rules?
So this is a standard list. It's actually coming, so those 300 plus tests, each of them has its own ID if you want, so all the rules are well known. And at this point, no, we don't allow you to add your own rules to that for a very simple reason, which is that we calculate the score and the security from that, and it's complicated to bringing some new stuff on top of it, right? So we're pretty reactive in adding a new list, new ones based on customer feedback, I would say. So if you wanted to have one that is really making sense and we think will be very useful for the rest of the customers from a security standpoint, you'll definitely be allowed to do that. Now the things that we'll be looking at is maybe, you know, extending the linting part of that I didn't really talk about. But we also do like, you know, OpenAPI validations. So some people have been asking us to do like, you know, I want a certain naming conventions and things like this that I want to enforce, or, you know, more about the structure from an OpenAPI perspective, or some extension must be present. There's more and more customers we are working with or adding their own X dash something in those files. So they want to make sure that when it's being audited like this, those extensions are actually present, for example. So that's the kind of stuff we're looking at in terms of extensibility, but not so much of the core of the security rules. Okay?
So, and these are standard rules from OWSP or something like that, or your own rules?
Yeah, it's really more like 15 years of experience in APIs and security poured into a, into a tool.
So this is like your proprietary?
Yeah, it's actually a huge piece of IP, which is, you know, copied along in many places now, but yeah, it's one of the core pieces of IP that we have, absolutely. Yeah, sir, sorry.
Along the same lines of this point. So those rules are, the security rules are intellectually, they go beyond OS top 10.
Yeah, they're related to, right? They're related to in the sense that if you don't put, let me give you an example, if you don't put any patterns, in your parameters, then you're opening yourself to SQL injection, et cetera, et cetera. When we'll talk about the dynamic testing, you'll see this is where we more link to the OWASP top 10, because here it's like, okay, maybe behind the scenes somebody is doing validation, so we cannot come up and say you potentially have a problem there. But when we invoke the API for real, then we know, right? If I'm sending you something wrong and you answer anyway, then I know you have a problem there, right? And this is where we do the OWASP testing. OWASP link, I'm sorry. Any other, yeah?
Just one more question about that related to the rule. So when you add a rule,
Mm-hmm.
who reviews the rules? But because you guys decide to add a rule, right? Then you guys review the whole rule, or the community review it, how does it work?
No, it's really us, really, yeah. It's really our CTO and innovation team that looks at that, security team that looks at the rules and adds them. So it's also, we're following very closely, what's going on, the evolution of some new attacks and some new problems. But at the end, if you look at most of the attacks on the APIs today, there's a lot of common ground, right? And probably half of them, if not more, would be very well, going away if people were just validating what they receive. Just there, just that. Just making sure you don't trust the data coming your way, that you know what format of the data is going to be. That's already going to remove a lot of problems, right? So there's not that much new stuff. It's just the way it's maybe exploited that's kind of different in some cases. Okay, all right, so that's our rules. So you can run this from here. You can run this from your CI/CD, okay? You can see that into your VS Code. So that's also the idea, is we just have the exact same tool that's being used by everyone. So that's another thing, right? So you have the same report and the same information across the board. We just exploit the results of that maybe differently depending if you're in security or if you're a developer, but the heart of what we report is exactly the same everywhere, right? A couple of things more that I wanted to add to this, which is important. It is fast, as you've seen. Right, so that's another big problem that we hear from a lot of customers, is like some of the maybe static analysis and analysis tools can take hours to go, right? A long time to go. So you cannot put that in the pipeline because it's going to just slow everything to hell, right? So you just do it from time to time. You can't really do it systematically every time an API is actually changing, right? So that's another key thing that we did, is just make sure it runs in seconds, so that indeed it can be part. We have a customer now, they have 19,000 APIs in the system, and more than 4,000, I think, developers just running this all day long, right? And it's part of every single pipeline within the company, and that's okay. It's all fine, it works, okay? All right, so let's continue our journey here on beyond discovery. All right, so the next thing is, so we know what we have, we discover things, so back to the rules. So what are the rules that we want to put in place? What do we want to enforce as part of our processes, right? And this, so I've just jotted a few things in here, which probably are the most common things that we see across that really make a difference, right? First of all, as I said, start with validating everything. We know that. I think the OWASP has been saying that for about 20 years. Don't trust the data that comes your way, validate it. Now, the difference between traditional application security and APIs is that in APIs, the other thing you have to validate are the responses. Back to, Stu's point here about how do I control the data which is being returned, right? In the OWASP top 10, the number 3 is basically about that, right? It's excessive exposure, which is we're returning a ton of data back to the client, and for the client maybe to extract 3 fields out of 100. I think the most infamous example of that has been this Uber thing that happened about 2 years ago now, when they discovered that when they were getting the profile of a driver, this was returning this huge, like 150 line of JSON structure with everything you wanted to know about a driver, including the mobile token they are using to actually connect through the application, right? Game over. So, right, controlling that. How do I control that? Well, you're not going to control that unless you know what the data is, right? So that's really important. Obviously, validating all the tokens, right? We have authentication in place, again, adapted to the risk. It's not the same. Maybe you have an API that doesn't need authentication. You know, like in Spain, I know most of the banks, they have an API to find the ATMs around you. This is an open API. It doesn't have any authentication. It's kind of, you know, useless to get people to get an API key to just have that information. But obviously, if you do a transfer between bank accounts, that's a very different story, right? You don't want to leave that open. So again, back to the risk. What is the risk and what do we want to do? It's more expensive for someone and more complicated to maybe do, you know, in the open banking, you also have digital signatures, right? Just to not only to have the data, but digitally sign it and prove, you know, where this is coming from. Maybe you want to encrypt it. All of that has a cost. Right? Is that cost adapted to the risk? That's the key question we have to ask ourselves. Rate limiting, that's obvious. As I say, you know, no authentication, no rate limiting, opportunity for a lot of great stuff, right? So I don't think any reason you wouldn't have some kind of rate limiting on your operations. And again, this is something you have to design, right? You have to design. It's not the same to do rate limiting on the password reset operation, right? Than again doing rate limiting on gate ATMs. Not the same thing. And then you will have to go and validate that. Fine-grained authorization. This is really critical. If there's one thing to take away in terms of, you know, rules. API 1, so the number 1 in OWASP top 10 is this thing that, you know, the traditional security guys will tell you this is IDOR, like, from, you know, we've always known it with that name, right? And now they called it BOLA, Broken Object Level Access, right? And this is really about making sure that, you know, Isabelle, I'm connected to my application, I have access to whatever, resource 1, 2, 3, and Frederick comes in with a valid token, and he also has access to that operation, and he also wants to connect to and see account 1, 2, 3, but it's not his. Right? It's mine. You're not supposed to do that. How do you put that in place? This is #1 problem today. And it's #1 problem today because it's really hard to do this because it's at the data level. It's not about blocking the access to that operation. It's about making sure you know who's calling, what is the data you want to access, and blocking that if the two things don't match. Right? So that, if you don't design properly, adding that to your application after the fact, it's going to be a big nightmare, right? So this.
Talking about, to some extent, in some industries, there are people that use role-based authorization, but a travel agent is acting as your proxy. But that's not the same as what I would show you on the app that I know where you logged in. But it gets very difficult because it's 5 hops down the road, and who's really actually looking at this?
Yeah.
And is it a proxy or whatever and passing along?
It's really.
It's an unsolved problem right now.
It is a complicated problem. Yeah, it's the same thing in healthcare, right? You have a patient record in healthcare, and there is a part which everybody can see, okay? And then there are 3 parts where it's only your GP, you know, and then there's like that last part where it's only your specialist for whatever, oncology, right? And that's even worse because then you have to filter not only that you have access to the record itself, but data within that record. So depending on who is calling, you have to return different data. So again, this is not an easy problem, but it's always been there. We had this thing called XACML at some point that allowed to do that. And so right now we have OPA, we have open policy agents that allow us to write this kind of policies. And again, this is the kind of stuff we need to, you know, think about hard. Managed secret is another big thing, right? As I always say, what is the #1 repository of API keys in the world? GitHub. Exactly. Right? And they have all those great tools to go and find them and all that stuff. But, you know, and it's so easy to make. That's a mistake which is so easy to make, you know? So it's really hard to go and find the stuff. Security headers, okay. Libraries, we'll talk about that. All transaction logs, that's another thing that which for me is really hard to add after the fact. If something is happening in your system and you don't have any logging of what's going on, you're gonna shoot in the dark. You're gonna be like, I have no idea why this thing has happened, right? And the more microservices you have, the worse. Because you hop up and up and up and up, right? It's like this started here and it went there and it went here and it went there and it went there, okay? When did something wrong happen, right? So this observability story is also a very critical one, right? And make sure we do. So why am I talking about all this is because once you have decided about all those rules, then you have to check you're actually complying with them, right? It's not enough to just say, we're going to do it this way. Now we need to test for all this, right? We need to automatically test for all this. We need to test that if Frederic is trying to get in with 1, 2, 3, it actually does not work, right? We need to test that if I don't have any authentication, it actually does not work. I'll give you an example from I won't say the name because they're well known, but and people I talk to with one mistake. So a developer, without wanting, right, goes to their central API management system and decides to remove a policy because it's too expensive in terms of latency. Right? It's like they have done this great performance testing and everything points at that thing taking like 100 milliseconds and he's like, I have no idea what this is going. Boom, removes it. Okay, cool. Performance is great now. Okay, very nice. And, and a week later, somebody, a partner of that big company calls and said, do you know your APIs don't have authentication anymore? Right? So all the partner APIs, the guy had removed entirely authentication. Everything was open bar. A good thing that it was just for partners and it was publicly advertised, so he saw it before, cross fingers, nobody saw it, right? But why this could happen? Because he removed that in development, right? He didn't remove that in production. He's a developer. He's not allowed to do that. So it means that change went all the way, boom, 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 all the way to production with zero testing that what happens if, right? So that's the hard part. And again, if you don't automate that, you're going to be in trouble. Right, so ensure we're complying with the rules. And there's tons of stuff you can do in here. There's a lot of things, and I'll show you something now that we do, right? Or you know, Snig is doing as well. So what do we have? Right? We as 42Crunch, we're really looking at OpenAPI and the code, etc. Right? Now there's many other things which are moving parts in your application, as we saw in the beginning. You have your components. Like, how do I know that the components I'm using is not something that I'm actually, you know, inherited from and now has a CVE, right? How do I test for that? And I have to test for that. So the software component analysis, that's really critical because again, you import version X and usually it's very hard to know that maybe that version X has a problem now if you don't detect it automatically, right? Of course, code analysis. I guess most of you do code analysis automatically as well, right? So we saw, you know, 42Crunch, that's what we do. We do more like a contract analysis, which is kind of the equivalent of doing a SaaS, but for the API contract. You want to do all of that in dev, right? Now, in QA and testing, the key thing you want to do is this, you know, implementation testing. So, and I was to say, what's really, really important is this blue line here, right? Everybody is great at testing 200 OK. No problem there, right? We all know when it works, and we'll discover if it doesn't work. The problem is when a hacker hacks your APIs, he's not looking after 200 OK. That's not what they're after. As I always tell my customers, the guy is not going to read the documentation to make sure he actually follows the rules of your docs. He's going to do all the contrary. right? It's going to go and try every single thing against the system to see, to trigger something that would then allow them to pull from that thread and find something else and find something else, right? So you actually need much more negative testing than you need positive testing. Of course, you need to know it works when when it's given some good data, but you also need to know. So that's really important. Container, images. There's all this like poisonous thing now, like to bring, put some improper version of something in a Docker Hub or something like malicious environment. So some code gets pushed into GitHub, it gets compiled, boom, ends up in Docker Hub. You download this, you use it, and it's a Trojan horse. It happened not so long with a Kubernetes environment, right? So you have to validate that as well. What is it that we're bringing in? Making sure we actually validate that, right? And production, we'll talk about that later. So let's have a look at a more complex example of a pipeline that we do. So that I can show you that. It was supposed to be there. Why is it not there anymore? Okay. Oops, that's not mine. That's mine. Actually, I'm going to show it to you here. Come on. What? Why? Is that working? Okay, well, that's fine. We'll find it. I'll go and get it from there. If you don't want to show me there, okay. Let's clean up all that stuff. All right, so we've seen that before, right? The contract audits, this is the same as what I've showed you in GitHub Action. It's just the Azure pipeline version of it, okay? Now, the second service that we have in here is something we call the Conformance Scan. So the idea is to take the OpenAPI file and use that as the source to generate a number of security tests, right? Our goal really is to make sure that the actual contract is in line with the implementation, okay? Or vice versa, if you want. Implementation is in line with the contract. Something that might have changed, right? But also what we want to see is, have we really documented every possible error code within that contract, right? Most of the contracts I see, again, 200 okay, all good, right? The 400s, maybe the 500s, none of these are actually present in the original file, right? So what we will do is we'll just hammer the API with all kind of bad data, bad verbs, bad whatever, just to make sure that all the responses we get, A, are documented, B, are properly documented, so we know about those return codes, and B, the content of the message that comes back is actually what it should be, right? So we're not starting sending you back some exceptions when you should really send you back some proper message code, for example, right? So you can launch that. This is a special setup that I have, but this is all open source for our customers. This is like a wrapper around the agent that actually does all this testing. Most of the customers, they want to do this on-prem. They don't want to do this from our SaaS, right? So we have a Docker image with that scan. This is that scan agent that you see in here. And we've created either something in AWS or something in Kubernetes, so you can run this as a job, basically as a batch job, right? So you can have a centralized deployment of that. And then what your developers, all they have to do is really to run this with a curl command. And actually right now, we also are allowing you to do this from directly your, if I can find something in here, right, directly from your IDE, right? So that interactive testing you can do straight from the IDE as well, and then run from the pipelines, okay? So again, same principle. The developers, they can do all this testing. They find all the problems. They fix them. And then we rerun the same thing from the CI/CD pipeline. We apply the same security gates on the results. So we find some type of problems in that report. Then we will block, again, the deployment because it does not comply with the requirements of the company, et cetera, okay? So let me just launch this now so you can see what it does. Well, maybe not. I'll see. Well, I don't know why it doesn't want to give me access now, but okay. It was working, as you can see, 2 hours ago. Okay, that's fine. Okay, we'll just go in here. That's okay, no problem. So I'm going to show you what it does with an existing report. Sorry about that. Whoop, do this all the time. Damn. Here we go. All right, so what does it do? So the first thing the tool will do is do what we call happy path testing, right? So think of this really about as something to create a baseline of the functionality. That's the 200 OK. It's like, if I'm sending you the proper verb with the proper path, with the proper data, it's all good. Okay, we're happy. Good. Once we have done that, then we'll start, doing testing of other, first of all, what happens if I'm sending you some wrong verbs? There's a lot of discovery that happens in hacking by simply trying other verbs. It's actually well, I think it was Github, actually, or GitLab, I remember. A bug bounty where they found that their framework was really interesting. When you were doing a head on their API, which should not have been allowed, right? For some reason, I can't remember what the language was, the programming language was, but they had a programming language framework that was set up to say, you said head, you probably mean post. Okay, so you were sending it a head, and it was actually executing a post instead, which was like, what? No, that's not what we want to do. So it leaked to, I don't remember the details, but, again, if you don't test this kind of stuff, you're not going to know until somebody tests it for you, right? It's always the same story. So we'll try all of those, and all of those should fail, right? And they should all fail in kind of the same way, right? So you can see this API really is not, if you send it a get instead of sending it a post, it will actually bark some HTML at you, right? Which is not what we want. Sorry, what was that? I heard music. You guys didn't hear music? Okay. All right. All right. So it will send you back some HTML. So that's the first thing, very basic thing, right? But we do it automatically. So we'll just go and test all the operations, okay? Second thing is, for every single piece of data, what we're going to do is inject a data outside of the constraints, right? So let me just go back and get the full list here. So what happens if I'm sending you a content type that you're not supposed to accept, right? You're telling me in the contract that you're supposed to get application JSON. If I'm sending you something else, what happens? Well, you should reject that. But we don't, right? That API, for example, incorrectly tells us, I'm happy, I got your thing, I'm handling it, okay? And then, so that's not correct. And the second thing which is incorrect is the response, right? This is supposed to be JSON, and it returns some text, right? So that is wrong as well, right? And as you can see here, in the end, behind the scenes, what do? Well, we generate some curl command with data that we generate from, again, the knowledge in the OpenAPI file. So it's also very easy for someone to just, take this. We actually have a tool that we put open source. Yeah, it's open source. That takes that report and generates a Postman collection from it. So if you, for a developer, it would be very easy to reproduce this as a whole, or indeed, as I was just showing you, but we just announced that, run this straight from the actual IDE, okay? So they can reproduce this pretty easily. What else? What do we do here? We send it a Boolean, right? So we sent a Boolean of sending a string, and that's exactly the kind of things that we don't want to happen, right? We now have an exception trace that is talking about Node, that's talking about JavaScript. So we know now what is behind the scenes, right?
So when you're setting out these data, right,
Mm-hmm.
what about the remaining parameters?
So if you have examples, we'll leverage those, right?
Examples in the OpenAPI.
In the OpenAPI file, right? So, and you can also create some input. This is a new version we're working on right now, where you can input also more advanced, I would say, data sets if you want, right? But for the testing like this, we really don't want to send some good data. That's the whole point. So I tell to customers, we want to send good data. I'm like, no, you don't want to. And we want to send them in a certain order. No, you don't want that either. You have to test all that stuff in random order, because that's what, again, hackers are going to do. They're not going to follow the list of things that you are supposed to do a proper use of the API. And they're going to do it in any order they want, okay? So yeah, for every piece of data, we'll generate that, we'll do all this testing, right? So we know at the end, if you have 0 problems on this, your API is capable of basically handling anything coming their way. They do proper validation, they do proper error handling. They will only respond to what is actually allowed, right? And people find all kind of problems that they had no idea about with this. Because again, like this head becomes a post, right? There are plenty of predefined behaviors in your code and API management environments. So, for example, we have plenty of customers that have different results if they go straight into their API and if they go into an API management. Because again, API management says, oh, you're returning a 400 now. Yeah, I'm going to transform that into a 403 or whatever it is, right? Or vice versa. So until you actually test this, you're not going to know, right? Okay. All right. What else do we do in here? Oh yeah, of course. And then if there are constraints around the data in terms of this data is required, this data is, you cannot have additional properties. All this stuff that you've expressed as constraints will test automatically. So every time, again, an API is being published, every time you want to run automatically those tests. And you can take this, we have some customers doing that as well, taking the results, creating Jira issues and Github issues, etc., to be able to track those systematically, okay? All right. So, go back here. All right, so yeah, for me, one of the key things here, because we're shifting left and doing DevSecOps, is whichever tools you're choosing. So as I said, we think we do a pretty good job at this, but there are other things that you will have to inject, not us only, right? To test everything, that entire stack. If you put in your pipeline things that take a long time to execute, that cannot be accessed easily from the development workflow, what we see is just pushback, basically, right? Is because it's already complicated for developers to actually deliver the applications that are being asked to deliver on time. Like they're really focused on, whoever's a developer in the room, right? The focus is on delivering. You have a sprint to do and 2 sprints, and you have to deliver that functionality. So if on that path to your goal, there is something there that takes 1 hour of your life every time you push a line of code, then that is not going to do it, right? From a security standpoint, it's really bad. All that's going to happen is some boss is going to talk to another boss, and that's going to be removed from the pipeline, and off goes the security, right? So the whole scalability of this for developers is really, really critical, right? So make sure you do that. And also, we've seen that a lot, is make sure it integrates within your ecosystem. Again, so developer workflow is also very important. But this data, it needs to be pushed to your Jira or your whatever. The results need to be pushed in your SOC for security monitoring. So you need something that fits inside, whatever flow you have, also from an ops actually perspective, not just from a dev perspective. Okay, so we've seen that. Okay, and the last point is the security as code. The last thing I wanted to actually show you, but I have to fix that problem in Azure DevOps first. Which is to detect attacks and prevent exploit, right? So once we have tested all that stuff, now we have to put some active protection in place. And again, deploying the protection also needs to be automatic. And the reason it is automatic is because of my friend here, developer, who removed the authentication. That cannot happen. No one should be able to just remove a protection like this from an API management without, well, no one knowing that's the testing part, right? But you want that to be systematically added on top of your APIs as you go and you develop them, right? And it's the same, you know, it's just where we have this great benefit with OpenAPI, which is, you know, JSON and YAML based, which is text, basically, right? So here, and because, and thanks to the fact that OpenAPI is extensible, we can put all those X dash blah, 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 right? We can add a lot of things into there in terms of what is it that we want to enforce as rules, okay? The constraints. So we have the native constraints, which are like all these things about patterns and min lengths and max lengths and formats, et cetera, et cetera. If we are allowing additional properties, what is required, what is not required, all of that has an impact on security, right? But on top of that, we can declare a lot of policies. You know, if a lot of API management solutions actually doing that, like AWS is a good example of it, where they will allow you to put some snippets of their policies within an OpenAPI file, and when you upload it to their platform, they will consume that and deploy the protections, right? So this is really good. It's much better than putting it manually within the gateway itself. The reason is that, you know, as you go and deploy, because you have to pass through that pipeline, you know it's going to be added and nobody can remove it after that. That's the first thing. And if somebody removes it, he will remove it, or she will remove it from the OpenAPI file. Then you have a track and say, oh, this has disappeared, right? It needs to be approved. Why is this not here anymore? Or we can inject it on top, which is what we do, for example, right? Which is injecting those policies as part of the pipeline on top of the file. So nobody has to do it. It happens automatically, right? And what this is going to enable is something which is really critical, which is a positive, which is a positive security model, right? The main problem we have, and we've had for 20 years in security, is we're using a negative security model. We're focusing everyone on the things we do not want, right? The majority of the, you know, that's web application firewalls, for example, the way they work is they will receive a big bunch of strings, right? And they'll look inside and see, is there anything in here that matches one of my known patterns of problems? And if yes, then what I'm going to do is stop this, right? And for APIs, this is really problematic. I don't know right now any one of my customers that do anything in WAFs beyond the very basic, like maybe SQL injections, because that's like super, super well known. It's been for so long, right? But all the rest of the specific top 10 of APIs, it cannot, because it doesn't have that context. It doesn't understand, you know, it's a string, right? It doesn't know if it's a field that contains a doctor name or whatever, right? It doesn't know about any of that. So by doing a positive security model, we say, okay, we know, right? This is the description of the data. We know what should be sent, and we know what should be returned. Therefore, we can actively say, okay, this is fine or this is not fine. And we're focusing everyone on not defining the threats and describing the threats, but rather on describing what it is that we want to accept, right? Which is a very different concept. So it's not new in security, obviously. You know, it's been there for a very long time. But it's traditionally been very hard to build a whitelist so we understand each other, right? An allow list. Now, this is our allow list. It tells you, this is what I'm going to accept, right? And if there is something else in here that is not ID, PIC, or email or password, I will reject it because it says here, additional properties false, right? If something else comes in, doesn't have to be there, so I'm going to reject it, right? So again, what this is allowing us to do is very early in the life cycle in DevOps to put in place that protection that will filter the data inbound, outbound, and tell us, is that acceptable or is that not acceptable? And we can do this from the first day we're actually writing our API, right? We'll know so we can refine over time that allow list and make sure when we get to production, we have something that really works well, okay? So let me see if I can fix my access issue here. So I'm not exactly sure why it doesn't want to go to. Let's see if it lets me do that. I can run it but not see it. That's pretty cool. Okay, that's fine. All right. All right. So what we're going to do in here, we're going to do this audit, right? Make sure it's all fine. I'm going to launch that scan interactively. So do this interactive thing. Just for the sake of the demo here, I'm not taking any actions on the scan result. So it goes and passes, okay? And then we'll see the step here that says inject protection policies, right? This is the step in here where we basically enrich our OpenAPI file with additional policies, such as validating, injecting security header, the rate limiting, actually have, that's not in the race here, some JWT validation as well, right? Because it's one of the big problems we see at our customers as well, is how do we do systematic JSON Web Token validation? And in the end, the JSON Web Token, what is it? It's just two pieces of JSON, right? You have the header and you have the payload. Well, actually, a payload can be anything you want, but most people put JSON inside, right? So when we receive a JSON Web Token, it's not enough to actually just validate the signature. You have to validate much more than that, right? And this is part also of the new testing rules that we're putting together, is to actually allow customers to create JSON Web Token on the fly, which are wrong, right? So that you can make sure that you are not accepting a JSON Web Token you should not be accepting because it doesn't contain the claims you want, because it's not signed with the algorithm that you want. There's an entire RFC on how to properly validate JSON Web Tokens, okay? So this is the runtime part of it. Yeah? Mm-hmm.
Looking at your console operator, it says will be injected. Does that mean is it injecting the
Let me show you.
policies into the actual spec?
Yes. Yes, that's what it does.
The reason I bring that up is because I talked to some folks where they're concerned that adding certain extensions, right, or any extensions for that matter, whether it's AWS to import and build the proxy or gateway or any product for that matter, that when a consumer comes along and says, okay, I'm a consumer API, let me look at your OpenAPI spec, that they actually see those extensions and what they need and that using. So they're saying, well, perhaps somehow, some way, inject on the fly and whatnot, or have two copies.
Two versions, yes. Yep.
And one for the backend loads.
Yep, absolutely. That's what we do. So the version I have in GitHub is the version that would be the public one. And this one does not have any policies in there. It's vanilla, right? But if we look at it in here, once it's been imported, right? So I just ran this, right? You see 19, 16 feet, well, or almost there, right? So you see this is the report that has been generated that just ran as well, automatically. And now in terms of protection, so if I look at that file, you will see at the bottom, right? This is the type of stuff that has been injected, right? So this has been injected automatically. We're going to validate security headers and remove headers that give too much information. We're also doing some request limiting automatically, and we're doing validation of JSON that's been injected in there as well. So at the operation level. GWT, here it goes, right? So you can also put this at the operation level. It has been injected as well, right? So in the file that people see, they will not see that. That's only for us, really, and for us to consume, right? And what else did we do here? Well, we have deployed this, the third part of our platform, really, which is a firewall, right? So we call this an API firewall. Think of this as a runtime component that sits in front of your API and will just filter all the data coming in and out of your API, right? So as part of that deployment here, I had an existing API. I injected our firewall in front of it. So now everything that goes through that API is actually going through our runtime component. And the effect of that is, so if I'm going here to to something here like Postman, right? So if I look at this API, so this is actually a public thing that I just created. Oh, actually, I have to change that base URL in here, otherwise it's not going to work. Sorry about that. Here we go. Because this is the official one, so there we go. It is not on port 8090, it's on 070. Okay, and it's HTTPS. All right, I should do, let's go back here, yes. Oh, that should have been part of this, all right. All right, so I have this user, so this just one operation I want to show you that allows you to create a new user within an application, okay? So as we saw in the scan testing, we had plenty of problems there. When we were doing a get, remember it was like barfing some HTML at us, right? So if we look at that get again now, instead we're gonna get this. So this is our firewall responding, because it has intercepted this as a no, that doesn't conform to the contract, you can't do a get on that operation, only post is allowed. So it will answer instead of the API in front of it, right? Then, anything, because we know the data again, so we know this is an email, for example. So this is something which is impossible to do with a WAF, right? So we know this is an email. I don't care if this is like whatever, an invalid JSON or SQL injection or anything like this. What I care is this must be an email. So if it's not an email, it's going to be stopped automatically, right? So we validate automatically what is coming in here, and we'll stop it. And the same thing will happen. So let me just go back and get a valid user here. I should be able to log in, get a token. Right? The same will happen, so this API, I should have shown you before, is actually leaking password data. Right? So when you ask it to give you the list of all users, it will give you all the list of users, including with their passwords. Right? So here, as you can see, it's on the request we're blocking, it's actually the response. So when the response comes back, we look at it and say, whoa, no, that's not good. All right? And we replace the response by something else. This can be configured as well, but by default, we replace it with something which basically does not give away what's going on, right? The idea is if you're a valid user, you have this UID, and you can go to people and say, hey, what is going on with transaction, whatever, right? There we go. So then we'll tell you, hey, no, can't do, there's a password in there, right? Another thing which is really important here is the time we take to validate things. This is usually the first question I get. It's like, oh yeah, we're gonna put something into traffic that validates everything. How long is this going to take? So there's a really huge amount of IP, again, probably the second biggest one, on how fast we do this thing. Because if it's not fast, people are gonna remove it. That's very easy, okay? So as I say, again, from an automation perspective, the idea is you have the OpenAPI file, you've scanned it, everything is fine, you take it, you deploy the firewall automatically, right? So we know it will be there, nobody can remove it. You can really put in place some true security all along the life cycle. That's really the idea of our platform. And this is pretty much what I had for you guys. If you have any questions or comments, I'll be happy to take them. No? Well, I'll be here all week. Well, 3 days. Thank you. So if you have any questions or anything, pass by the booth as well. Happy to give you all the information you want. Yeah, Frederick. Sure.
It's about the security requirements.
Mm-hmm. What do you mean? Yeah. Yeah. Mm-hmm. Security requirements. Yeah. So we look at those, and here, you know, if I'm not passing a token, for example, so here it passes it automatically. Sorry. So if I don't send this, right, this is going to be stopped automatically because the contract says that you require a token. The scope, it will be an extra policy if you want to do that, but yes. So if the scope doesn't correspond in the token, yeah, you can do that too. All right, thank you very much, gentlemen.